My name is Dennis Horton. I am a licensed private pilot, and I'm going to explain a few ways that math comes into effect when we fly. First thing you have to do is figure out a weight and balance. In other words, the planes that I fly are not huge planes, it's small, it only weighs 1,700 pounds. So you have to get your total weight, your passengers, your fuel, and any baggage. Figure out the center of gravity with all the weight in the plane. The particular plane that I fly is a 172 Cessna. And each particular plane has different criteria as to how to figure out weight and balance. This is a simple chart of the center of the gravity. This is a chart that shows you which information you use to figure out weight and balance. Each compartment has a different measurement. Like the pilot and the passenger has what they call an arm, which is the distance from a given point for the center of gravity. So the passenger and the pilot have an arm of 37. The rear passengers have an arm of 73. So what you do is you take the total weight of the passenger and the pilot, multiply it times 37, and it'll give you what they call a moment. So you take that moment, put it on the side, and then you have the rear passengers. You take the weight of the rear passengers, times it by 73, and that'll give you another moment. What you do is you add those two moments together, and if it falls into what they call a center of gravity envelope, if it falls into this envelope here, your plane is balanced. If your weight is too far forward or too far aft in the plane, it is unsafe, and the flight controls will not act the way they should if the plane is out of balance and it's an unsafe airplane. Another way we use math in a flight is prior to takeoff. We call for what we call a weather briefing. Basically, the most important thing in a weather briefing is weather, what the weather is going to be, but also is wind direction. Let's say we're going on a flight from Republic to Poughkeepsie, and we have a wind direction of 340 degrees at 17 knots. In other words, this is the wind direction at 3,000 feet. So we have to figure out which way this wind is going to push us in the air. We have to compensate for that by what they call a wind correction angle. So what we do is we get our true course, which is the distance from Republic to Poughkeepsie, which is 14 degrees. What we have here is basically a slide calculator, slide ruler. We take the wind direction, which is 340 degrees. We mark up from the center 17 degrees, 17 knots for the wind speed. Now we take our compass direction and put it at 14 degrees because that's our true course. And we show that the wind correction angle is 6 degrees. It's a minus 6 degrees because it would be on the left side of the compass rose here. So we take 6 degrees off from our original 14, which gives us a true heading of 8 degrees. Now also what we have to take into consideration is what we call as a variation. Variation is the difference between magnetic north and true north. And in this area, it's plus 14. So we take our 14 degrees from our true course minus our wind correction angle of 6 degrees gives us a true heading of 8, plus the variation of 14 degrees gives us a magnetic heading of 22 degrees. 22 degrees, which once we're in the air, we want to fly at a magnetic heading of 22 degrees to compensate for the wind at 340 at 17 knots. Once we're in the air, we want to figure out how much time it's going to take us. So we have calculated that it's going to take us 14 minutes to get from Republic to the north to the Connecticut shoreline. Now it actually takes us, let's say we get up and it takes us 20 minutes. So now we know that the winds are a little stronger and it's going to take us longer. What we have to do is do a time, rate, and distance calculation. If we look on this particular plot, we have a ground speed of 94 degrees, ground speed of 94 knots and 14 minutes. 94 miles an hour at a ground speed, at a distance of 14 miles is going to take us almost 9 minutes. 8 minutes and 50 seconds according to the chart here. But if the wind changes, we have to know how much time it's going to take us to get from point to point, because that'll depend on how much fuel we burn and how much fuel we need for the flight. So as you're flying along, if the wind is not exactly what they say it is, you have to be able to figure out how much fuel you have on board by a time, rate, distance chart.
Okay, so
I know I screwed that up a little bit in the middle there.
Alright, I'm just going to say about, alright, so when you're on board, do you have to do any mathematics, or is that all just prior to the...
Well, if, let's say you're in flight and you go into Poughkeepsie, and now Poughkeepsie gets fogged in, you can't land there. You have to take these same formulas, find out what are you going to go to another airport. You have to pick another airport to go to. And you have to be able to take the same calculations, and figure out what compass heading you're going to go to, and how much fuel you're going to use, how much time it's going to take, and do you have enough fuel to get to where you're going. So you have to be able to, in flight, change everything around and use these same mathematical formulas.
Okay. Alright, sounds good. Thanks for your time.